Well, welcome to another quick short video on Great Cow Basic. This is a 10-minute video which really shows you a tool I built. It's a meter monitor with integration to Google for spreadsheeting and graphing. And so what have we got here? We've got a microchip microprocessor. It's an 1825. It could be anything. It's got a sizable piece of memory. In actual fact, what I've actually got attached to it is also an LCD display, a real-time clock, a piece of EEPROM. And I've actually got a Telnet processor and how that connects into Google Graphs and Google Graphing. So basically, I've got some switches. It's the switches that I'm actually counting. I'm actually counting actions on the K1 switch, and K2 and K and these other two switches are actually for user interface. But so what I've got is a microprocessor, some I2C processors, and some information. So what does it do? If we look at this screen, we can see that it's a computer. It's actually a terminal, and it's actually getting the information on the screen here from the microprocessor. It's actually coming down through the RS-232 line. It's picking up time, date, and values, and other changes directly through this processor. It shows you the time coming from the DS1307 real-time clock, the meter values, the amount of energy that's being consumed, and then it's got two lines that are currently empty because we haven't actually done an update to Google yet. It will actually send this information directly to Google. These scripts are available and are quite useful. What else is on here? It's actually a Perl script that's running. It's a very simple Perl script. It picks up XML coming out from the microprocessor. It's a couple of similar, very simple lines, and it then displays that on the screen. The Telnet processor in Perl then processes it on the hour and sends the information directly to Google Drive. Google Drive is a spreadsheet, and excuse that. And the spreadsheet is then updated, and then from that you can actually do some graph. So what have we got? This is actually on the test bed. It's actually live now, but this is when I was on the test bed a few days ago, and this is actually the display. What we've got is an extensive set of menus on this thing, because it's got the amount of energy that's been used, the time from the real-time clock, and that 0 or O tells you the state of the switch. Is it on or is it off? And you can see I just pressed it there once on test, and it actually just used a unit of energy. The menus are extensive, and we'll look at those in a moment. But essentially, for each depression on the K1 switch, I get an increment of a decimal point, and the code handles the pseudo decimal points because clearly it's an integer. The information is then stored, and it's stored alongside that with the dates, the current meter reading, the time the microprocessor is restarted. You can actually zero that. That's important to know that it's been restarted. You can set the clock, you can set the date, you can zero what's called the hour count, the amount of energy used in the hour that's used for graphing. You can set the meter value itself, and then you can set a reference point, which is what's called the baseline. And the baseline, it just tells you how much energy has been used over a period of time. So we've got about 10 or 12 menus that we can actually select from. So I'm pressing the K2, K3 buttons. Now these are the menus. These are all done within Great Cow Basic. All the strings you can see in blue here, and in the K1, K2 menus, they come from the EEPROM. Everything defaults back to level menu 0 after 10 seconds, and that just times out using a timer function. And so if you get confused about what menu you want, you just wait 10 seconds, and it will then time out. It will take you back to menu 0. So the menus I walked you through a moment ago, in terms of dates, times, meter values, etc., and all the questions. This is from this simple flow diagram here. You can set the clock. The clock has it stops the DS1307 real-time clock, and it allows you to set it. otherwise you'd be on a moving target, and the meter, etc. And this is pretty important interface. Now I had a version of this code before, but I didn't have the flexibility that I've managed to put together on Great Cow Basic. So let's have a look at that user interface in a bit more detail. So as I said, all these strings here are coming from the EEPROM, and here we are. I'm setting the baseline, and what you do is you can sort of increment through these baselines. I'm setting a baseline value, and you can see that as you're going through the decimals, then you walk through the units. You can then it sort of walks you through the options. As you can see, I'm just incrementing through by pressing the K1 button, and when you press K2, it then sets the value. So you've just got two buttons basically on the unit. There it's just timed out and took you back. So it's whilst you're doing that, it's still counting the values of the meter. It's still getting all those inputs. Setting the clock is slightly different. You actually have to slightly different approach. You decide to set the clock. It always sets it to hours, minutes, and then the seconds. So you actually set the hours and then the minutes. After a short while anyway, I've just shown you there that the LCD actually turns itself off to power down the whole unit. It's still counting, but you can actually turn it on and off from the two button interface. And so when I push it again, or I get any inputs, the LCD will then turn back on. It's just a way of saving power basically. In actual fact, the LCD is controlled through another microprocessor, which is just a kit which I built. It's only a couple of pounds. It's just a lot easier to send it these command strings. So essentially, this is now a live meter. It's actually operating, and if anyone's interested, I can show you the URL, and you can actually have a look at the information, the data. And so I'm just going back through the menus. And here I'm setting the time. As I said before, you have to set the hours first and pressing the increment button. It's walking through. You set the hour, I think, and then you set the clock again after you set the initial hours, and then you go back in and set the minutes. As you can see, it rolls over in at the right time. And what I successfully did there is managed to get it incorrect. So we'll set it to 9. Oh, no, we set it to 10. There we go. And so what it actually does is every time it updates, it sends a string down into that terminal. If you're looking at the black terminal on the bottom left hand side of the screen there, you can see that Google has actually responded now with a value. I've got a value 200, which basically means the transaction has been successful. And that is, so it just took a K1 switch count. It took it down the serial line to the Telnet processor written in Perl, and then popped that off to Google Graphs. The graph itself is quite sophisticated and works very well. But essentially, this is why I fixed the I2C bus, because I wanted to replace my current meter monitor and put some greater interface on it. And now quickly into the IDE, and I'll just show you very quickly. This is the actual language file. This can be translated very quickly. This is pretty simple utility. You just take the strings, and then it creates the input file to the EEPROM for you automatically. I've done that as part of this project, and I shall be using that extensively in the future. So there we have a meter monitor based upon Great Cow Basic with an integration into Google and Graphs. I haven't got time to share the Google and Graphs in details, but trust me, it's updating Google, and the information of my energy uses is sitting in Google. That's a wrap.